Now we've gone through these now. You should feel quite comfortable, but if you don't, please do just go back again through the video, or go through your book, or go through the past paper questions. We're going to look now at cracking. You need to know the definition of cracking, and that's converting your longer chains into shorter, more useful alkane and alkenes. You only normally get one alkane, so I probably should maybe cross that off. I don't know if that would make more sense. And conditions, there's two conditions you need to know about, and uses. Your shorter chain alkanes are used for fuel. Your shorter chain alkenes, however, are far too useful to use as fuel. So we use them to synthesize other chemicals like plastics, alcohols, and a vast range of other chemicals, and we call that chemical feedstock. It's worth noting that this is a chemical reaction, so it follows the law of the conservation of mass. So if you have 15 carbon atoms at the beginning, at the start, and 32 hydrogens, you're going to have the same number at the end as well, meaning no atoms are lost or gained. So if you count how many carbons there are in that alkane, there's 8, therefore we're going to have 18 hydrogens in this alkane, and then you have a few alkenes. So you have an alkene with 3 carbons, that's going to be, and then you have 2 of the same alkenes with 2 carbons, which is H4. Okay. So this is what cracking looks like in the lab. You have your alkane, your longer chain alkane, just soaked in mineral fiber. It has to be mineral fiber so it doesn't burn instead of cotton wool or anything else. And then you have your catalyst, which is your aluminium oxide. Your heat is directed at the catalyst to heat it up. It could be alumina, which is aluminium oxide, or silica, which is silicon dioxide, and it will be directed, and some will be directed to the organic molecule here, and that's just to help vaporize it. So it goes over the hot catalyst and cracks. Now, I would recommend just pausing and sketching this diagram just so you are clear about what is happening here. And we use underwater displacement here to collect the gas. Okay, so I'm going to give you, there's 7 marks here, so I'm going to give you 7 minutes max, or give yourself 7 minutes max just to answer these questions, and you can pause now and we'll go over the answers afterwards. Okay, so for decane, your answer is this, and is these two. Remember, you always get an alkane and an alkene. You could get more than one alkene though, so just make a note of that. And then your conditions are there. Cracking is important because any of these two reasons as to why cracking, any of these reasons as to why cracking is important. Okay, so there's 5 marks here. Give yourself a max of 5 minutes to answer these on a scrap piece of paper if you like, or somewhere more permanent. And we'll go over the answers in a moment. Okay, so the cracking of octadecane produces octane, and one other product. Give a chemical equation for this cracking reaction. Now you could just use the law of the conservation of mass to help you here. You should have got this. Why is it important to crack long chain hydrocarbon fractions? And you could have had any of these 3 marks to get that. And it says write an equation for this incomplete combustion of octane to produce a poisonous gas, and it's going to be carbon monoxide. You don't need to include the carbon here, so just carbon monoxide is your product.